Today, I'll be talking about the polar and rectangular representations of a sine wave. I'll explain what the polar, rectangular, and sine wave form is, and how you can interchange between them in calculation. First, I'll talk about the theory. Sine waves. AC circuits have an alternating current given in the form of a sine wave. Therefore, the voltage is a reflection of the sine wave. Due to the relationship that exists between them, known as Ohm's law, V equals to IR. The sine wave form is given as amplitude times sine Wt plus theta. Next is the rectangular form. Complex numbers are used to solve AC circuits. Let's say we have an AC circuit. A resistor has a non-imaginary effect on the circuit, but something like an inductor or a capacitor has an imaginary effect. Thus, the rectangular form is complex, given by x plus imaginary j times y. Finally, the polar form. Polar form is possible on a normal 2D graph with an x and y axes. Polar form is given by its magnitude and its angle theta. It is also possible on imaginary numbers too. The vertical axis is known as the imaginary axis, and the horizontal is known as the real axis. Therefore, the magnitude is given by r equals to square root x squared plus y squared, and theta equals to tan inverse y over x. Now for the maths. To move between sine wave and rectangular, you have to go through polar. It is quick and easy, so don't worry. First, let's change between sine and polar. Here are the general forms. Theta in the sine wave is equal to the theta in the polar form. They're the same. For the magnitude is the amplitude divided by square root 2. So it's quick and easy to move between polar and sine. But when moving between polar and rectangular, it's much more difficult. It's split up into two parts. First, from polar to rectangular, r cos theta equals to x and r sin theta equals to y. Then, from rectangular to polar, r equals to square root x squared plus y squared, and theta equals to tan inverse y over x. Here's an example. Try and do this by yourself. And here's the answer.